Hi all, welcome back to Oops with C++ session 27. In last section, we have discussed on the compilation process of class and object, and we have also discussed that irrespective of how many objects you are going to create, each object is having his own set of the data members, and all the objects are going to share the single copy of the function definition. And also we have discussed when all the objects are going to share the single copy of the function definition, then how the function will come to know on which object it is working. So when I say emp1 dot set details or emp1 dot display, how this display function will comes to know that who is invoking me, so emp1 or emp2. So from because emp1 is also having employee id and employee name, and emp2 is also having emp id and emp name. So when you say display emp in the display function, we have given displayed emp id and emp name. How this display will comes to know whether I have to display from this memory location or from this memory location. And we also introduced a topic called this pointer there, and that is our today's topic. Okay, so what is that this pointer? So this pointer is a default argument provided by the compiler to the non-static member functions of the class, and this pointer is always supplied as a first argument to the non-static member functions of the class. So whatever non-static member functions we are writing, for all the non-static member functions inside the class, this pointer will be provided by the compiler as the first argument, whether you are providing the argument or you are not providing the argument to the functions, but the compiler will provide one default argument to that function, and that argument is known as this pointer. It is a pointer. Pointer means obviously it will holds an address of something. Okay, so what is this pointer? It is a pointer which holds address of an invoking object of that function. Say for example, if the set details function is invoked by emp1, then it will holds the address of emp1. If set details function is invoked by emp2, then it will holds the address of emp2. Okay, so whoever is invoking that function, that object address it will hold. Okay, now what will be the syntax of so this pointer is a constant pointer of the same class. So in that case, what is the syntax of this pointer? So this pointer is class name star const this equals to address of invoking object of the same function. It is a constant pointer and it is local to the function. So since it is local and constant, you won't be having access to this pointer once you come out of the function definition. Means you won't be having the visibility of this pointer once you come out of the function definition. And since it is a constant pointer, once some address is assigned to this, and you won't be able to make it to point to some other object, because this is a constant pointer. Since this pointer is a local to the member function and it is constant, so we cannot make this pointer point to some other object, and there is no visibility of this pointer once we come out of the member function. So this is the key point you have to remember. And always this pointer will holds the address of the invoking object of the same function, irrespective of how many objects you will be having. We will be invoking the function with only one object, right? So that object address will be holded by this pointer. It is local to the function definition, local to that member function. Okay, so now let us quickly have one program here, that is class C employee public void set details. So set details function, display function, two member functions are there, and two data members, emp id, emp name. And here we have set details function where we are printing this pointer value, whose address it is holding. So for that we are printing this, and it is having we are doing string copy employee name empid equals to empid, and also display function we're displaying this. So currently our focus, we will take only one function here for our discussion. I have created two objects here, employee1 and employee2, and here we are printing address of emp1. And by using emp1, we are invoking the set details function. When you are invoking set details function like this emp1 dot set details, then what will happen is, so internally the compiler will convert the statement something like this: address of C employee scope set details address of emp1 and next Richie and 101. So as I said, so first argument will be the this pointer here. So then instead of so address of so the first argument will be address of the same class object. So emp1 will be sent. And other so here we are doing address of emp2 and we are invoking set details with emp2. Now address of emp2 will be passed. So what we are expecting? First we are printing emp1 address, then we are invoking set details. So in set details we are printing the this pointer. So these two statements should give the same output. Okay, and these two statements should give the same output. Okay, just compile this and see whether we are getting the same output or not. Okay, a plus plus this dot cpp, so compiled successfully. So now you can see here address of EMP1 is 800F0 800F0 and address of EMP2 is 80100 80100. So by using EMP1 we are invoking set details function. So this pointer is holding the address of this one and EMP2 is holding so after address of EMP2 we are invoking set details with emp2. So in this section this pointer is holding address of emp2, so it is a local to the function. So now just observe whether it is the first argument or last argument. So we will conclude that by using gdb minus g, compile this program with minus g option for gdb symbols generation. Now run this GDB with a dot out with the GDB a dot out, set the breakpoint at main. Now run the program, go with single step. Okay, so now you can see here, so breakpoint I have kept at main. I'm going with this one single step address of emp1 equals to address of emp1. So next step, so the output of this is so address of emp1. Okay, so now what we are doing is emp1 dot set details. So when I call this this actually internally which method will be called, so you can see it will be called C employee. How this statement is getting converted? C employee scope set details this next name, so id. So these are some garbage values. So still the values this address and this is not uh, sent to the arguments. Okay, so still it is empty values. Okay, so it will be called, you can see right, this is the first argument to the function. Okay, so now single step, you can see this pointer equals to this. Now it is printing this value, this pointer equals to 0xffde70. You can see right, address of emp1 is 0xffde70, so this value will be given. So from this it is clear that always this pointer will be as provided as the first argument to the function. So for set details we have only two arguments, but compiler is also providing one argument, that is this pointer. So that is this pointer is a default argument provided by the compiler to the, I'm quitting this to the function definitions or to the function member functions, that to only non-static member functions. Okay, so now uh, let's see this program and analyze how it is happening, how it is identifying the proper object. So now whenever I'm going to create same program I have taken, so constant character star name, set details and display. So here I'm not printing only the address here. So whenever we create C employee emp1 emp2, then what will happen is, so the two objects will get created, emp1 and emp2. Both are at the different memory location. One is at 1000 memory location, let's say another one is at 1016 memory location. Now what we are doing is we are invoking this set details function with emp1 dot set details. Now, when we say emp1 dot set details, a separate stack frame will be created for this set details function. So in that set detail function, so totally we are having only two arguments, that is name and ID, but compiler is providing one more argument, that is this. So totally three local variables, local arguments, that is three local variables will get created in this stack frame. So that is this pointer and name ID. So now by default, who is invoking this set details? emp1 dot set it details. So emp1 is invoking. So address of emp1 will be sent to this pointer. Now this pointer will hold address of emp1, and name will hold Richie, and ID will be having 101. Now this pointer is holding this. So when I say string copy emp name comma name, what will happen is the control CPU control will check. So where is the so now the compiler will generate the code like so is there any local variable present inside this stack frame? So with the name emp name. So there is no emp name present here locally. So now it will look for this arrow emp name. So this it is arrowing to this object, and here emp name is there, and this Richie will be copied here. So next emp id equals to id. So now again it will look for, the compiler will look, is there any um, variable with the name emp id is present locally? So it is not there. So then again it will look for this arrow emp id. So it is present here. So now the value will be copied from this to this object. Okay. So after that, what we are doing is now the values are copied here 101 and rich. After that, that stack frame will be removed. So now there won't be any visibility of this pointer. Now again what we are doing is for emp2 also we are doing the same thing, emp2 dot set details store stop 102. So now again same procedure. So again stack frame will be created. Now this pointer will be created, local variable name will be there, and ID will be there. But this time this pointer is holding address of emp2, that is another object. So now when I say now string copy emp name comma name, then what will happen is emp name here. So there is no local variable present here in this stack frame with the name emp name. So now it will look for, the compiler will look for this pointer where it is pointing. It is pointing to emp2 object. So emp2 object is having emp name. Then copy the name of name value to emp name, and copy the id value to emp id. So it will copy that one. So after once it is copying is done, then all this pointer everything will be removed from the memory. The stack frame will be removed. Now emp1 and emp2 is initialized. Now in the same way, if I do emp1 dot display, now display function also will having a stack frame. Now only one local will be variable will be there, that is this pointer, and this pointer will be holding emp1. Now when I say emp id, then it will display emp1 emp id. When I say emp name, it will display emp1 emp names, because this pointer is pointing here to emp1. So in the second case, this pointer will point to emp2. So it will give the information of emp2 object. So like this, we can use this pointer. But with the help of this pointer, the function members will get a clarity on which object it has to work and whose information it has to display. So now a small assignment here. So what I did is I just modified the local attributes parameters name here. So instead of name, I have given emp name. Instead of ID, I have given emp ID. So means it is same as the data members of the class. So now here I am doing string copy emp name comma emp name, empid equals to empid. Now do one thing. So take this program as it is, compile it, and see what is the output you are getting, and analyze why you are getting this value. Okay, and how can we resolve this? Right. So once you resolve this problem, then come to this second assignment. That is same thing, but here only thing you can see here is emp1 dot set details. After that, I am using display function. So means two function with the at the same time I am invoking. So but here set details first, then display, set details, display, like that I am displaying. So now two functions set details display both I am invoking at the same time means function concatenation I am doing. If I want to perform this task, what I have to do, what modifications I have to do for this code. So hint is use this pointer. Okay, how to use, think of it. So that we will discuss as an applications of this pointer in the upcoming session. So that's for today. Thanks for watching.